Pain is a decision by the brain based on a perceived threat. There's this very interesting quote: whether we feel pain or not is very variable and is largely a product of the circumstances of the injury as assessed by our brains. Now, when I went to school 25 plus years ago, we used to say that tissues were sending pain signals up to the brain. Let's say you sprained an ankle. Okay, your ankle's sending pain signals. That is now incorrect. Yes, that ankle that has been sprained is sending signals, but it's merely sending what we'll call danger signals. The technical term is nociception. So there's these danger signals alerting the brain of a potential threat here. So the brain will decide, and we'll discuss this a little more detail in the next couple slides, but the brain has to decide, do I have to make pain? Pain is produced by the brain. Why? To protect. And so if the brain sees a potential threat to our body, to our life, it may make pain to get our attention. It may make pain to move us to act. So interestingly, in the brain, there is no pain cortex. There are certain areas of the brain dedicated to certain things. So in the back of our brain, we think of the visual or the spatial cortex. Other parts of our brain have the sensory, where we feel cortex, motor cortex, where we do our movement, that location of the brain where that activity is centered. But there is no section of the brain that is dedicated to pain. It was once thought there might have been. In fact, they tried lobotomies, frontal lobotomies, in an effort to scrape out the pain cortex. But there is no pain cortex, so those lobotomies failed. But what we're understanding today is something what they're calling the pain neuromatrix. It's a fancy sounding term. But what's been identified are 9 areas of the brain that already have day jobs. So like our motor centers, our memory centers, our emotion centers. These areas of the brain that do something as a primary job. These 9 areas have to activate to create a unique signature of every pain we experience. So think of it as a pain project in a corporation. Your corporation has multiple departments, and okay, we have this pain project, so each department has to send a worker from its department to this new project. And so you're diverting resources from those departments for this, quote, pain project. Well, the longer pain goes on, the more and more workers are diverted from their day jobs. More and more workers taken from those different departments for the, quote, pain project. So those areas, those day job areas, let's say the motor center, the memory, the emotion center, these are all getting affected. So we talked about cognitive processing being affected. Yeah, brain processing in general is being slowed down because now it has to do something it wasn't intending to do, which is make pain. And a very interesting thing happens. The more frequently brain cells activate together, the quicker they activate together. So there's a phrase in neuroscience: nerves that fire together wire together. So maybe we can illustrate it with a basketball team. Let's say it's a brand new team. None of the players have ever played together. So at first, they don't know each other well. There's a lot of sloppy play, miscues. But the longer those men or women play together as a team, they get better, more instinctive. They work well together. And that's basically how we learn. Our brain has a combination of nerve cells dedicated to a job. Well, the more those nerves work together, the quicker they'll fire, the better connected they'll be. And that's essentially how we learn a skill, whether it's music or sports. So the double-edged sword of this learning ability is that we can actually learn pain. So every pain experience that we have has a unique combination of nerve cells making that pain. so that every time we feel that pain, the same nerve cells are working together time and again, time and again. They're getting better at making our pain, which is why you might have experienced it would hurt after 30 minutes of walking. After a while, it hurts only after 20 minutes of walking. Hurts only after 10 minutes of walking, only after 5 minutes of walking. Why? Because those same nerve cells are just getting better at making your pain.